Your team spent 2 years implementing a data catalog. Now, nobody uses it. The problem isn't the tool, it's that traditional catalogs are built like read only museums. Here's what's replaced them. Traditional catalogs were built for centralized teams, managing hundreds of assets. Today's team manage hundreds of thousands of assets across distributed domains. That architectural mismatch is why adoption fails. Traditional data catalogs were designed around a simple model: extract metadata, store it in a proprietary database, and present it through a UI. The architecture for this looks like: first, source systems like Snowflake DBT and Tableau had their metadata extracted via APIs and connectors. It was then stored in the catalog's proprietary database. This allowed for reading of the information through the catalog UI and manual enrichment there by the data stewards. This made sense in 2015. Most organizations had smaller data volumes, centralized data teams, waterfall development cycles, and BI first analytics, not AI. The catalog was a documentation system. You'd extract metadata, manually enrich it, and present it as searchable index for business users. Here's what's changed between 2015 and now. We've had a volume explosion. Instead of hundreds of tables, teams now manage hundreds of thousands of assets: tables, columns, models, dashboards, ML features, API endpoints. Ownership has been decentralized. Data engineering moved from central IT to domain teams. Instead of 10 data stewards, you need 100. We've seen velocity acceleration. CI/CD for data means schemas change hourly, not quarterly. By the time a traditional catalog extracts and indexes metadata, it's already stale. And now we're pushing AI first use cases. Metadata isn't just for humans anymore. LLMs, agents, and AI assistants need real time context to query data safely. Traditional catalogs can't feed AI systems. They're built for human search, not programmatic access. The result of all of this? Many teams never fully adopt traditional catalogs, even after years of effort. For those that do, the catalog becomes what customers call a place where metadata goes to die, a read-only museum nobody visits. A metadata lakehouse flips the model. Metadata is first written into Apache Iceberg tables in Atlan's Metadata Lakehouse, stored in open formats on cloud object storage, and accessible to any user, human or machine, when needed. Here's the architecture. First, we get all the metadata from the source systems, Snowflake, DBT, Tableau, and enrichment from stewards. Then there's a continuous sync to Iceberg tables. This is then SQL queryable from any tool. In the end, now the UI is just one of the consumers of the metadata, not the only one. Instead of extracting metadata into just a proprietary database, the Lakehouse writes it continuously to Apache Iceberg tables. Those tables are SQL queryable from any compute tool that can utilize Iceberg tables, such as Snowflake or Databricks, and can be utilized to build your own dashboarding or custom scripts. The UI becomes just one way to access the metadata, not the only way. This changes everything. Here are 4 architectural differences between a traditional data catalog and the metadata lakehouse that matter. First, SQL queryable metadata. In a traditional data catalog, metadata is locked in the vendor's proprietary database. If you want to analyze governance coverage, you need API exports, which are rate limited, paginated, require Python scripts to stitch together. Getting answers takes days or weeks. But the metadata lakehouse, its metadata is stored as Apache Iceberg tables in the metadata lakehouse. You can query those tables from Snowflake, Databricks, or any Iceberg compatible engine. You can then join your business data and you can get answers in seconds with SQL. Our governance teams run queries like this against the metadata lakehouse. That's governance coverage by asset type in seconds, not days. No exports, no Python scripts, no delays. The next is real-time syncing. Traditional data catalogs run on scheduled extracts for this, with hourly or daily batch jobs. By the time metadata gets indexed, it's already stale. Lineage is updated after the fact, which means you can't use it to prevent incidents, only to debug them after they happen. However, the metadata lakehouse, it syncs continuously, every 15 minutes. When an engineer changes a Snowflake table, the metadata lakehouse knows almost immediately. That means you can run a query to see which dashboards, models, or data products will break before deploying the change. You move from reactive debugging to proactive impact analysis. The third is an open format, not proprietary lock-in. A traditional catalog stores metadata in the vendor's proprietary database. If you want to export it, you're stuck with rate-limited APIs. You can't extend the schemas, you can't build custom analytics, you can't feed it to your own tools. It's classic vendor lock-in. With a metadata lakehouse, metadata is stored in Apache Iceberg tables, an open standard. Any tool that can read Iceberg can access your metadata. Want to build custom analytics in Tableau? Go ahead. Want to feed it to dbt or Jupyter Notebooks? No problem. Zero vendor lock-in. Companies can build their own data product analytics dashboards by querying Atlan's metadata lakehouse from Tableau. They don't need Atlan's permission or APIs. They can write SQL against the Iceberg tables. Finally, AI native, not human only. Traditional catalogs were built UI first, designed for humans to search and browse. Their APIs are optimized for search queries, not for feeding rich context to AI systems. If you want to build AI use cases, you're back to manual integration work. The metadata lakehouse is AI native from the ground up. Atlan ships an MCP server that gives LLMs like Claude and ChatGPT direct access to structured metadata, search lineage, governance policies, anything you want. We also generate semantic views for Snowflake Cortex that combine schemas, glossary terms, quality signals, and access policies. Context for AI, not just data access. Atlan is one of the first data catalogs to ship a production-ready MCP server for AI tools like Claude, Cursor, and ChatGPT. Point your LLM to Atlan, and it can query metadata directly. What tables contain customer PII? Which models use this feature? That's not possible with read-only catalogs. Here's how this works in practice. Now, the old way with a traditional catalog, when a governance team needed to report on metadata coverage, they would call a catalog API to export the asset list, write a Python script to paginate those results, export glossary terms, owners, tags, all separately, join that data manually in spreadsheets or scripts. They'd build the report and then wait 2 to 3 days for a refresh. The total time it took? Days to weeks. Now, the new way with the metadata lakehouse, the governance team queries the metadata lakehouse directly by opening Tableau, Sigma, Power BI, or Looker, connecting to Snowflake or Databricks as an Iceberg Open Catalog client, querying a metadata lakehouse table like the assets table exposed via the metadata lakehouse, joining the related glossary, owners, and tags tables, building dashboards with filters by domain, team, sensitivity, or certification. In total time, hours. Because this is all just SQL on open Iceberg tables, the governance team doesn't need engineering support. They run their own queries, they build their own dashboards, and refresh them on their own schedule. Patterns like this are what enabled General Motors to cut time to insight from 28 days to 3 hours. Another example is AI assistants like Snowflake Cortex. They need more than just table schemas. They need business definitions, trust signals, and access policies. Traditional catalogs can't feed that context. It's locked in proprietary databases. Atlan Semantic View Generator reads the metadata and creates views in Snowflake that combine schemas, glossary definitions, quality metrics, and policies. Now, when a user asks, "What's our total revenue last quarter?" Cortex knows which tables are certified, what revenue actually means, and whether the user has access. The result? Significantly higher accuracy because Cortex has context, not just data. Now, you might notice, legacy vendors are starting to mention Metadata Lakehouse in their marketing, but they're not actually shipping it. Why? Due to 3 constraints. The first, proprietary lock-in is their business model. Opening metadata as Iceberg tables would kill their API licensing revenue. They'd have to rebuild their entire pricing structure. The second, architectural rewrites are high risk. Migrating from monolithic databases to Iceberg native architecture means rewriting 10 plus years of code. That's not a feature release, it's a multi year platform rebuild. And finally, enterprise inertia is real. Large customers with established Calibra workflows resist architectural changes. Vendors can't disrupt their own installed base. Meanwhile, Atlan has shipped an Iceberg based metadata lakehouse. Our customers aren't waiting for migration roadmaps. They're querying metadata tables in Snowflake today. Now, to be clear, traditional catalogs aren't always wrong. They still work if you have small, stable data volumes, a central data team that owns all metadata. You have low change velocity, like quarterly releases. You have no need for an AI agent integration, and UI only access is sufficient. But if you're in a modern data environment with decentralized teams, high velocity, AI use cases, the traditional model can't keep up. Most modern data teams are in the second category. If you're evaluating catalogs today, the question isn't which catalog has the best UI, it's do we need a read only museum or queryable infrastructure? Because once metadata is locked in a proprietary database, you're stuck. You'll spend years building workarounds, API scripts, manual exports, Python pipelines, just to analyze your own metadata. With a metadata lakehouse, metadata is infrastructure. Query it from any tool, feed it to any AI system, build any governance dashboard you need. That's the shift. Traditional catalogs document data. Metadata lakehouses power both humans and AI with context. If you're evaluating catalogs and want to see how the metadata lakehouse works in practice, check out our next video where we walk through setting up export-free governance analytics in Snowflake.